Hi everyone and welcome to the Learning Curve. In this video I will be continuing my review of typical final exam questions for university students studying Calculus 1. And here we're going to be looking at a double integration problem. Here we're asked to double integrate 2x plus y, firstly with respect to x and then with respect to y. It's very important to pay attention to the order in which the integration will take place. Here again, this is with respect to x, and then subsequently with respect to y. So we'll be using the inner integral first, which is the integral between 2 and 0, and we'll be integrating with respect to x, and then subsequently we'll integrate with respect to y to close the problem. So I will reset the problem like this: integral between 1 and 0, open bracket, integral between 2 and 0, 2x plus y, close bracket, with respect to x, then with respect to y. So we're going to put with respect to x in bracket here, and with respect to y outside, because that's what we'll do last. So let's go ahead now, and we're going to be integrating what's inside the bracket. So we've isolated the inner integral and with respect to x, the inner integral being the integral with the limits 2 and 0. We've isolated that as well as dx. So we're going to integrate with respect to x first over the limits of the integral 2 and 0. And then subsequently, after integrating and simplifying, we'll integrate with respect to y. So let's go ahead now. When I integrate 2x with respect to x, let's do that. I'm going to integrate 2x with respect to x. We will get 2x raised to the power of 2, because there's an invisible power of 1 here on this x. So we'll add 1 to it when we're integrating. We add 1 to the power when we're integrating an algebraic expression like this, and we'll divide by that new power. So the invisible one here, we add 1 to it to get 2 and divide by that 2. So that's how we'll integrate 2x with respect to x. And when we integrate y with respect to x, we treat y as if it's a constant, like 5 or 4 or just a number. And when you integrate a number with respect to x, you multiply that number by x. So hence treating y as a constant, because we're integrating with respect to x, it would become yx. All right, so that's the integral of y with respect to x, which is what dx means. So we get yx. And then I'm going to put the limits of the integral here, which are 2 and 0. That's the 2 and 0 right here. And then out here I put with respect to y. So continuing, let us now simplify the bracket. So this will be the integral between 1 and 0. The 2 here cancels each other, leaving us with x squared. We're simplifying inside the bracket. X squared yx, so plus yx. And I place back the limits of the integral here, which are 2 and 0, and then with respect to y out there. We're not going to carry out the integration with respect to y until I've finished substituting the upper and lower limits here, 2 and 0. So I'll write back the integral between 1 and 0. Then I will substitute the upper limit of 2 into the expression in the bracket to replace x, because the integration was carried out with respect to x. So this will give me 2 squared plus, then this will be 2y, because I am using 2 to replace x. Let's put that in a curved bracket. And take away, we're going to substitute 0 for x here. So when I substitute 0 for x squared, I'm going to 0x squared. When I substitute 0 for x here, y multiplied by 0 will be 0. So all of the second piece there will work out to 0. When I substitute 0 for x, all of this will work out to 0 inside the bracket. So we can just put 0 and then with respect to y. Let's continue the problem up here. So we're going to have the integral between 1 and 0. And when I simplify what's inside the bracket, we're going to get 2 squared, which is 4, plus 2y. All right, 4 plus 2y with respect to y. So that's what we'll get there. 4 plus 2y Yes, 2 squared gives us 4, plus 2y. That's a simplified result of what's inside the bracket, and we're going to integrate that with respect to y to conclude the problem. So we're going to integrate 4 plus 2y over the limits of 1 and 0 with respect to y, which is what dy means. Now, when we integrate 4, which is a constant, with respect to y, we'll multiply that constant by y, so we get 4y. And when we integrate 2y with respect to y, there's an invisible power of 1 for y, so I'll add 1 to it, giving us 2. So therefore, I end up with 4y plus 2y squared all over 2, and the limits of the integral here are 1 and 0. No need to put back the dy here because we have now integrated. We have now completed the actual integration. And now we're going to substitute the upper limit of 1 and subtract the substitution of the upper limit of 0 after completing the simplification of what's inside the bracket. So, simplifying what's inside the bracket, I will get 4y plus y squared. 4y plus y squared, because the 2 will cancel the 2 here, leaving us with y squared, and the limits of the integral are 1 and 0, and we're down to the final stanza now. So now we're going to substitute 1 for y, and also 0 for y, and subtract the results. So this will be 4 into 1, 4 multiplied by 1 rather, plus 1 squared, that's when we substitute 1 for y, take away, now when we substitute 0 for y, 4 multiplied by 0 will give us 0, and 0 squared will be 0, so all of that would work out to be 0. So when we simplify this result, we will get 4 plus 1, take away 0, so the answer would therefore be 5. So the result of carrying out this double integral is 5 units, and that's our answer. All right, I hope this was very clear, and if you have any questions, you can please post them in the comments. Remember to like, share, and subscribe. I will be continuing this series on working typical past paper questions in a Calculus 1 final examination for university students. This can also be helpful content for students who are studying advanced level mathematics, GCE A-level examinations, or other A-level examinations such as the CAPE examination in the Caribbean region. Thank you very much. Looking forward to seeing you again soon as we continue our indulgence in the world of mathematics.